Okay, the last part of Unit 1 is about volumetric analysis. This is where we can use concentration to determine the amount or moles of a unknown solution. So a titration, you usually have a known solution and an unknown solution, and then you react them, and you can use a colored indicator to show when those two solutions are at equal moles. And then from the volume, you can find the concentration. So for example, if we were to take sodium hydrogen carbonate and react it with sulfuric acid, we have a reaction. We know the mole relationship between those two based on the coefficients, 2 to 1. And then we can figure out the moles of NaHCO3 because they gave us the volume and the concentration. So to find the moles, remember concentration is equals to mole over volume. So concentration times volume is equal to moles. We would need that to be in the correct unit. So centimeters cubed needs to be converted to decimeters cubed. And so we would move that decimal 3 places to the left. And so the concentration times the volume would give us the moles. And so we have 0.0025 moles of NaHCO3. So using the concentration and the volume of one substance, you can get the moles of that substance. Then we can use the mole ratio and the balanced equation. So 2 moles, because of the coefficient, to 1 mole would tell us that we have 0.00125 moles of H2SO4. And since we have a volume of H2SO4, we can then divide it. Just remember it needs to be in decimeters cubed, so we're going to go ahead and convert that. And we have a concentration of 0.082, let's see here, 3 significant figures, sorry, 2 moles per decimeter cubed. So that's what volumetric analysis is taking the concentration and volume of one substance, a balanced reaction in the volume of another substance to find the concentration. And again, it's based on a titration, which we would be able to find when the moles of those two substances are fully reacted based on this indicator. All right, so let's look at another example. We have hydrochloric acid, so HCl, is being completely reacted with sodium carbonate, so Na2CO3, sorry. So we would switch our partners. We would get NaCl and then H2CO3. Now, H2CO3 actually does not exist. Instead, what happens is that will further decompose into water and carbon dioxide. So anytime you get a product of H2CO3, you really should erase it and write H2O plus CO2. And then we need to balance it. So we have 2 sodiums and only 1 sodium, so we'd put a 2 there. That gives us 2 chlorines, so we would need a 2 here. 2 hydrogens, 2 hydrogens. There's 1 carbon and 1 carbon. 3 oxygens, 1 and 2 make 3, so it's balanced. So what is the volume in centimeters cubed? And then it gave us the concentration of acid, and it gave us a mass of sodium carbonate. So we're going to take our sodium carbonate, and we are going to convert that to moles. So finding the molar mass off the periodic table, we have 105.99 grams of sodium carbonate is 1 mole of sodium carbonate. Okay, so then we need to find our moles of HCl. So we set up our mole ratio from the balanced equation. So when we multiply and divide across, the grams of sodium bicarbonate will cancel. And then the moles of sodium carbonate would cancel. So grams would, okay, it's not working. Grams would cancel, moles will cancel, leaving us with moles of HCl. So 0.536. And since we know the concentration, we can find the volume. So concentration is equal to moles divided by volume. Multiply by volume on both sides. Volume times concentration equals moles. Divide by concentration. Volume is equal to moles divided by concentration. So we're going to take our moles of HCl and we're going to divide it by the concentration that they give us. So moles would cancel. So we would have 0.357 decimeters cubed. The question though wants it in centimeters cubed, so we're going to convert. Decimeter to centimeter is one place to the right, so we're going to do that 3 times because it is being cubed. So we would have 375 centimeters cubed as our final answer. So really what volumetric analysis is taking the concept of concentration and the concept of stoichiometry and kind of putting it all together. Let's do one more example. So we have zinc and it's placed in carbon 2 chloride, and we want to know what the mass of the zinc would displace. So if we set up our reaction, zinc and copper 2 chloride, remember zinc always has a charge of 2, so that would be ZnCl2 and copper, and then it's a balanced equation. We don't need to add any coefficients there. So what we have is a volume and a concentration of the copper 2 chloride. So from that we can get moles of copper 2 chloride, and then we want to solve for the mass of zinc. So we're going to first find moles of copper 2 chloride. And so if we remember, concentration is equal to moles over volume. Multiply both sides by volume. Volume times concentration would give us our moles. But we need the units to match, so we're going to have to convert centimeters cubed to decimeters cubed. So we would move the decimal 3 times to the left. So 0.435 decimeters cubed times 0.770. Our decimeters cubed would cancel, giving us our moles. So we have 0.335 moles of our copper chloride. And then we can use our balanced reaction and we can just do a conversion. Copper chloride. And 1 mole is 1 mole of zinc. So remember, we have to show that mole ratio to go from copper to zinc. Even though mathematically it doesn't do anything, you do need to include that. And then we want not moles of zinc, but the mass, so grams of zinc. So from the periodic table, 65.39 grams is equal to 1 mole. And so we would have a mass of 21.9 grams of zinc. All right, so again, don't be frightened by these problems. You're just having to put different concepts together now. Make sure you fill out the Google form and try those problems from the textbook.